For today, I've asked Sebastien Pahl to do a quick overview. So Sebastien, if you want to share your screen and your few slides and take it away, that would be great. And then we'll move on to Tom Bentley and we'll have some Q&A in between and we'll see how fluid this whole meeting is.
Perfect. Thank you very much, Diane. All right, so let's get started. I'll keep this not in presentation mode because I want to jump to websites real quickly. So quick introduction, like what is an operator and what are we doing here? Rob touched a bit on this point. Our goal here is to build applications that have Kubernetes native APIs. And what that means is we want to take complex applications like, for example, Postgres or Kafka, which there's going to be a good talk about right after me. And we want to take all their logic and all the complex knowledge that is in each application and put it into a program. We want to be able to operate it automatically. We want to be able to leverage all the features of these applications that have to do with upgrades and other pieces. And we want to do it behind Kubernetes APIs. Why behind Kubernetes APIs? Because that way you have one way of managing all your applications. It's nice to build a single Docker container where you're going to have your application packaged in a way to run it anywhere. But we all know that applications get much more complex than that. And they require multiple containers. And then they require operational knowledge. What do I do with these containers? How do I deploy them? And that is specific to each and every single application. There's not one application out there, or at least there's a lot of different applications out there, and they all have their own quirks, their own operational knowledge. And it's really only the experts of these applications that know how to install them and operate them. And that's not even talking about when we get into the Kubernetes world. We chose the Kubernetes world because it allows us to create one standard way of doing that. And we want to give you tools and tool sets to help you build these applications. And I'm going to talk a bit more about this in the future. So how do you build an operator? What does it even mean to be an operator? So what we just defined a while ago and CoreOS kind of kicked off a few years ago was the idea that you could use Kubernetes CRDs, which are these custom resource definitions to which you can then post new resources on Kubernetes. And you can basically build an API that looks exactly like Kubernetes and that you can use with kubectl, and not just kubectl, all the tools that are able to talk Kubernetes. And you're able then to use that API to drive the entire application. And you want to encode all your best practices about that application, all the application domain specific knowledge into that operator. So upgrades, for example, when you're going to kick off upgrades of an application, you want everything to be in there to be able to do that smoothly. Same thing for failure recovery, scaling up, scaling down. And that's, I'm just scratching the surface here because we all know how complex applications can get. So the idea is if you build an operator, you can then do that in one single place, and then people can reuse that operator just like they've been able to reuse Docker containers. And that's quite powerful. Like getting it from having to learn everything about that application to being able to start it up in a second and worry about it anymore. And Rob mentioned a good point, which is it's the same feeling that you have when you're in the cloud. When you're in the cloud, and for example, use AWS, you go to you want a database, you provision an RDS, you basically do an API call, and you get an RDS database, and then you more or less forget about it. Like there's still a lot involved, but you at least have something that's running and that you can count on. And that's the feeling that we want to replicate on any Kubernetes platform, whether it's in the cloud, in your data center, and bring these services that take any open source application or closed source, but mainly open source applications, and bring that cloud native feeling and usability to your Kubernetes cluster. And you can build these operators with just like, in the end, it's a Kubernetes controller for those who are familiar with that. There's a loop that runs and you're able to react to events, and then you basically do what your application needs depending on the event that came. Or you can use tools that I'm going to talk about now, like the operator framework that will help you build those and help you not have to know about need to have intimate knowledge about all these Kubernetes specific things that you might not want to know about. So what is the operator framework? The operator framework is, for now, it's 3 projects that kind of work hand in hand together. The first one would be the SDK. The SDK is, how do you build that? How can we abstract as much common code as possible between all these operators? Because if everybody's going to write an operator for their application, as much as there's domain-specific knowledge on these applications, there's also a lot of similar things. I like to use the example of TLS, right? Everybody needs to deploy TLS certificates, manage TLS certificates, and also be able to rotate TLS certificates. That is something where, while the rotation and the deployment of these TLS certificates is specific to every single app, the common codes to be able to generate those certs, to basically use a single one-liner to tell it, for example, on a Kubernetes deployment, I want this to now have a TLS cert in front of it, that can be abstracted away and used in a common manner across multiple applications. And so it's things like this, and also tools for upgrades, for metrics and others, that we want to encode into the operator SDK so that people have a very easy time to build operators. I hope everybody's following me until now. The next step, once you have an operator, is, well, an operator is good, but that's just one application you run once. And then what if you have multiple versions of these applications in your cluster? What if you want to upgrade them? What if you want to upgrade multiple at a time? That's where the lifecycle management comes in, and I'll talk about it a bit more later. But Rob mentioned it. It's a problem that people don't know they already have. It's basically the next step. And then metering. Another thing that building things with an operator can help is you can actually then take all the interesting metric that, and that's specifically interesting for people like ISVs or which is you can encode in your operator all the logic that you need to bring back the interesting metrics that you need to know. Is my application doing well? And also, how could I, for example, as a vendor, bill against my application? And how do I know if I'm inside of, let's say, AWS? How do I know how much this single database table or even row costs? Of course, that requires quite a bit of logic to write into the SDK, into the operator, but that logic can then be aggregated through the operator metering toolkit. So I'm gonna go again on all of these through each of their websites. And there's a question. I'm just gonna check if it's a question. We'll answer that later. All right. So mainly, that's the main goal of this presentation, is how do I get started? Where do I go? Where do I start? So the first part is obviously our operator framework org on GitHub. And there you have all the projects that are related to these things. One thing, you have lists of operators, and I want to also go into each project individually. So if you go, for example, to the SDK, you can see that that's the project. That's where you get started. And I want to talk a bit about how easy it is to basically get started. If you're familiar with something like, and not everybody likes it, but it's a good analogy, Ruby on Rails. When you do Ruby on Rails, you don't have to know the intricacies of HTTP. You don't need to know the intricacies of Postgres at first. And you can get started by basically using models, views, controllers, and you can also generate quite a bit of code, and you get a lot of utilities with that code. That's what the operator SDK tries to do, but for the Kubernetes world. So I'm showcasing like the getting started because it shows quite easily that you generate your application, and then you're able to build it. You put in your domain-specific code, which was happened here, which is a much longer process than this shows, of course. And then once you're happy, you're able to build, push it just like any container, and then deploy it. And here it shows a deployment by hand because we don't have a lifecycle manager yet, but that's just an example. So I encourage you to come here. There's quite a bit of stuff to have a look at. This is just the getting started guide. We have quite a bit of documentation, the user guide, and more interestingly, if you're interested in knowing how you build your first operator, we've put in an example to show how you could build a vault operator with this SDK. And to go a bit more in like technical terms, because I'd like to explain that here. This is the basic structure of an operator. It has multiple, like it has all the Go dependencies and everything, and then you would put your logic into one place, which is, for example, here. And you basically writes a handler. This one is a very simple handler that's now calling other pieces of the code, but the basics of an operator is really shown well here, which is you have a loop, you receive events from the Kubernetes API, and then you basically work on those events to do what you need for your application. So I encourage you to have a look at that part. Let me look for questions. Right.
There are a few.
Yeah, I just want to make sure that there are questions that might be used better to respond right now versus at the end.
Yeah.
No, I think we can keep these for QA. All right. The next step is basically the operator lifecycle manager. That's the next place I encourage you to have a look at. This repository is quite simple to use. It also has the same getting started guide as everything. You don't need to, it works and it will eventually be included in OpenShift, but you can install this on every single Kubernetes cluster. And that is an important distinction, because if imagine you have to use different, variety of Kubernetes styles, it doesn't matter. As long as it's a Kubernetes compatible cluster, you can install that lifecycle manager. And what you get out of this lifecycle manager is basically a repository of applications where you can then decide to deploy these applications in a multi-tenant fashion. That's one of these goals. The lifecycle manager is aware of Kubernetes namespaces. It's able to tell it, and it also does one other important thing. It manages the CRDs so that users don't have to install them themselves. They don't have the permissions to do that. They only have the permission to then use the lifecycle manager, deploy and upgrade operators. So it's something that is quite useful, and also allows to abstract a lot of code that people usually encode in their own operators. Like that's what we've seen in the past. People tend to build an operator or what we call an operator and put in a lot of this logic that can here again be abstracted in one project, in one way of doing things. And that's it. And then the metering part. The metering part is a bit more complex to install, but it is also installable on every single Kubernetes cluster, and is basically our goal, and it's not completely integrated yet, but our goal is to make it so that once you have metering and OLM installed, if you deploy any framework any operator that has been built with the operator SDK, you will immediately be able to see those metrics and those and be able to build reports about usage in your cluster from all these applications. The last part I'd like to highlight is we've made a list of operators. Not everything here uses the operator SDK, but if you've built an operator, I would encourage you to contribute it here, to highlight it, and basically this repository is probably going to get curated more and more. We're going to show off what's built with the operator SDK, what's not, what can be used, but right now it's basically a list of many things. But you can see that already a lot of people have liked the operator concept and started building what's called an operator for their specific platform. I don't want to vouch for the quality of each of these, since they are not like going through any certification process whatsoever. And that's where the operator framework also comes in. Our goal is not just to help you build these operators, but eventually our goal is to help you test these operators, make sure that they work, that they behave well in a lot of environments. So we want to build through the SDK, a common way to test them and to certify them on the platform like OpenShift. That is what's going to transform a list like this, which you've all seen in the past for various applications, containers, and basically know, yes, that's a list. I still have to do my own research, but with once we're a bit further down the road with our testing kits, you'll be able to know, oh, this actually has been tested out automatically on the kind of Kubernetes cluster that I'm running. And won't have to use lists like this, and we'll be able to go in a much more automated fashion, and you'll be able to trust it much more than a random Docker image, for example. So that's a quick intro through all of that. And then the last things I would say, take a look at our Getting Started guide. It's much more in depth than just the one on the operator SDK that I showed off here. It is an end-to-end test with operator SDK and the lifecycle manager. We'll throw in the metering in it eventually, but this will enable to do everything that I said, try out everything what I said in a single Kubernetes cluster quite easily. Like just follow this and everything will become much clearer. The last things I would like to add are we created a channel to talk all things operator on the Kubernetes Slack, and we also have a Google group. These links will be shared by Diane after for everybody who wants to join. So that's it. That is the main thing that I wanted to do and what I wanted to highlight. Quick intro and showing you what each and every one of these components are.
All right. Well, thanks, Sebastien. I think that helped kick it off and set the groundwork for, and especially the concepts and the links. And I will add all of that into the gist and into the mailing list as well. There are a couple of questions, and some of them have been answered in the Q&A and chat. But I think if we go back to Alexander Lazik's question, and I can unmute people, it's two as well. So if Alexander wants to follow up on that, find you.
Sure.
And you have muted yourself, Alexander. So
I'm not. Yeah.
Can you hear me?
Yes, now I can hear you. So why don't you ask that question out loud, and we can have a conversation about that as well. We'll work our way through the Q&A.
The question is, you have always in combination with CRDs, but the operator themselves can run on Kubernetes kinds like ingress or routes. So do I always need the CRD, or can just run the operator and listen on the routes or ingresses without any CRD?
So I'll take that one. The goal of our framework is to go through CRDs. Like, of course, you can write Kubernetes. Like, if we forget about the framework for a second, you can write a Kubernetes controllers that does all this, right? That listens just to specific things. And also, the operator framework itself is also capable with the SDK of listening to specific objects. But what we're trying to do here is kind of an opinionated pattern where we drive things through CRDs because it allows us to, like, you need to put that API somewhere. And if all your controller basically is doing is like doing some ingress work, or let's say watching a couple of stateful sets and doesn't need to be basically influenced through a CRD, then it's not necessarily you don't necessarily need to use something like the SDK, but you can still call it kind of an operator. Right?
Cool.
You want to add something, Rob?
Yeah, I was just going to say that in like your case, if you're orchestrating like an external DNS provider, the CRD still might have a place for you to hold configuration. So say like the external Amazon zone that you want to write these DNS records to, and then you want to listen on the routes or and then, hook up the services or whatever. So I think there's probably still a place for a CRD in there because you need that configuration for what this thing is going to do, even if you're listening on other resources.
Yeah, we have talked in the Slack channel. Perfect, thank you. This helps me a lot.
There was also a related question right on this in the chat, which was about whether or not the SDK would make it possible to run reconciles against built-in resources other than CRDs. Maybe you could add on to that, Sebastien.
Sure. I mean, you can. The goal of the SDK itself is to reconcile everything from the CRD top down. That doesn't mean that you can't do it. It's just a pattern that we have adopted that we kind of prefer for the most common use case.
But like, for example, you could listen for pod events in your namespace if your operator cared when pod came and went, for example, even if it's still driven top down, right?
Yeah, actually, there's even like I could share an example of an operator that actually uses the SDK and does that. It was one of our partners during launch at Summit.
That might be an interesting thing to add the link into.
I will just need to find it. Okay, next question.
While you're finding that, I can
right.
answer there was a question about metrics example. And so this is really interesting for when you're modeling a really complex application. Say that you're an IT administrator and you're running, you've got 30 different engineering teams that are using your shared infrastructure, the Kubernetes cluster. And they all want to run databases for whatever reason. So you've got, you've tested out this Postgres operator, but you're running, say 30 copies of it, and every team is running databases with the operator. And then say you have a node failure or you have a networking blip or one of your AZs goes out. If that Postgres operator is instrumented to start emitting metrics about when it's doing failover or when its shards or whatever kind of underlying storage is not available, you can start to get a sense of like how these things impact the actual applications that folks are running without having to go around to every team and say, hey, did this impact you? Did you have downtime? Whatever. And you're getting like the actual application level metrics from Postgres itself or from this operator, so that it's really like not just generic white box like, oh, the network request went down, or like, oh, it's now using less RAM or whatever, which is useful information too. It's that you're getting a very specific thing. So another example, say you were running like a very large Gluster or Ceph cluster, that if you have to do heals on some of that underlying stuff as things are getting replicated around, knowing how many of those happen per hour or per week or whatever, and correlating that to cluster events can be really, really useful for you to help either make your operator more efficient. Why is this thing healing so much? Oh, I have a bug in my logic, or oh, it's just that the infrastructure is a little bit flaky, that type of thing. So you have all that insight if you have this metrics across the namespaces that an operator is running. And that aggregation is what's really useful.
May I have a follow-up question to this?
Yes. So David, why don't you follow up?
Thank you. Hello. I wondered if I would be able to make this metric system get a domain knowledge of my operator. So let's say I have a program and there I want to charge by users. So would I be able to plug easily the domain knowledge of my application into this operator matrix?
Yes, 100%. Those types of metered billing type use cases are perfect for this framework. And that's one of the exciting things that, there's like a set of operational things, but then also a set of business things that you can get unlocked by using this. And so, yeah, what you would do is in the SDK, we're going to build some functionality where you can say, I want to emit this metric that I'm already tracking. And then it'll get scraped by the metering system and then aggregated.
Yep. And if you look at the current pull requests or open and closed from the operator SDK, you'll see that it's actually being worked on right now to have metrics in either by default and also to be able to expose your own metrics.
I'd also like to call out that
Yep.
with at least metering, the actual getting that data is only the one half. And so like the metering component offers APIs, and long-term, we're going to probably build in default exporters that can basically, on top of the existing reporting functionalities that you already get, you can query the results out of these APIs. And so then the next piece would be for us to make it easy for you to get that kind of data out. For example, you said you want to know how many users are being used in your app, or how many there are. Once we have that, the next question becomes, how do you get it back? And so we're actually like really interested in like those types of use cases. If you have like, we want this data, but we also want to get it back home for us to use. That's one of the less the things that we're looking for more feedback on, since it's kind of up in the air still on how we want to achieve that, what kind of defaults we should be doing. So we'd love to hear more about that.
There's
Thanks,
another
Jens.
question in here that Yolanda is asking. which leads to another topic that I think is near and dear to all of our hearts, is interested in the lines between when to continue to leverage Helm for installing applications versus using an operator and how they complement each other. And I wonder if we could address that here, or if that's something we need another hour to do or whatever.
No, I don't think we need another hour. I had it highlighted here to give a quick answer. So one thing to know is that's actually somewhere where we can help quite a bit. So what we have is actually a Helm operator that is there, and you can use kind of very easily once you have the Lifecycle Manager installed, and that kind of gives your app quite a bit of ways of using Helm charts with operators, and you're able to use then Helm without tiller. You're able to use Helm without having too many privileges, which is something that is quite useful. And about Helm versus operators, I'll let Rom add for a bit, but like they complement each other, right? Like Helm apps are simpler apps that don't need as much logic as an operator would have. That's how I would say it quickly.
Yeah, and if you think about it this way, Helm is really good for running these stateless applications, but it's kicked off with like the Helm CLI, or it's like a human is in the loop there. And so one of the exciting things about the operator is you're taking that human out of the loop, and then you're making it Kubernetes native. So you're not having to write against a Helm API. You're just using a CRD. And the way our Helm operator kit, I linked it in the chat, works is you model, you don't have to model a CRD. A CRD is modeled for you that basically has your values that you would pass into a Helm chart as the configuration in the CRD. And then when you instantiate that, you have the image that the operator runs in actually has your chart baked into it. This allows you to version it with container tags, which is really nice. So you've got this immutable artifact. You pass in the values, and then out pop, whatever your chart is making. And so that's really nice because you're not having to run tiller, which has its own security issues. They're actually moving away from that in Helm v3. And then you're also now can apply Kubernetes RBAC to those objects. So within a namespace, if you want people to be able to create whatever your CRD is that this Helm chart makes or is listening for, you can say who can do whatever to those. And so you get all those, you get the Kubernetes audit log and all that type of stuff already built in. And then if you're using a UI that models CRDs, then you get a UI for free. So there's a lot of reasons to use Helm with an operator, especially if you've already invested in Helm charts. And then over time, if you want to add more stateful kind of stuff to your application, then what you can do is move it over to, I'll say like a real true operator, a Go code operator, and do the same thing, model those things, and then start building in your stateful logic. And so that's where we think the Helm operator kit is really nice, is it gets you started with an operator, and then you can kind of decide how much further you need to take it.
I know I can tell you confidently this works because I don't use the actual Helm operator kit we developed on the metering project, but I use a precursor to that is a Helm operator, and 90% of the components in metering are deployed using a Helm operator stack, and then that operator is actually what deploys the bespoke Go operator that does all the specific metering stuff as well. So it makes sense, even if you are writing a custom operator, what if you need to configure that operator itself, right? And so this is where like basic templating is really, really nice. And you don't want to write a bunch of Go code to just do some templating of some YAML basically, right? So there's a good place to be able to use both systems. And just a shout out too, people are working on an Ansible operator as well, like a similar kind of bridge for people who have playbooks to be able to interact with Kubernetes through a playbook with the Kubernetes modules in Ansible. And then the CR is kind of the edge trigger for your Ansible playbook and its inputs. So that's also coming up in the next couple of months. Thanks.